What's it called? Except on the Mrs. Donahue walks off and it's just us talking.
It's like joke time, not kids. It's like you have to be in the show.
It's just you making awkward eye contact.
Well, sorry, Jordan.
Okay.
Because he brought up his trail mix. He was eating it so instead of like, eating it, I eat my chapters like each time. Not really. Was he like hands going like this? He opened the bag and then he went. It was so funny. You don't eat it by like weirdly, and then you have to.
I need some of each kind.
I know.
I need M&M, a raisin, and nut everything.
I eat all the M&Ms and throw away. Peanuts are my
I'm just
kidding.
I'm just kidding.
Oh, maybe M&Ms. See, the M&Ms help the peanuts flavor, so I eat them together with the raisin.
Oh, yeah.
So in 28, we have to figure out what the A, B, and C are to begin with. That's probably the toughest part about it. Because A is always in front of the x squared, so in that case it's a 1. The B is always by the x term. There is no x term, so that means B is 0. And then that means the C is 4. Now, have you had those two flipped, it obviously will change your answer. So, now the A is 1, so I know it's going to point up, happy graph. So negative B, negative 0 over 2 times A. 0 is just, it's going to be 0. And then to find my other half of my vertex, I'm going to put the 0 back in. 0 squared is just 0 plus 4.
Oh,
So this is my vertex.
that is not what I did. I was like, 0 can't be like that. That's no solution. And then I put no solution.
Okay.
Why did I give myself a man voice?
Okay, so 0, 4. So there's our vertex. And then we were supposed to graph, was it to say like 5 points? Oh, name the vertex and the axis of symmetry. Remember, the axis of symmetry is just the vertical line that goes to this point. So it's always just the x coordinate. So x equals 0 is my axis of symmetry. Then they wanted you to graph it, so you're going to pick a couple of their points.
X, Y.
Okay. So 1 and 2, negative 1, negative 2. And when I go put these numbers in, so 1 squared is 1, plus 4 is 5. This is also 5. 2 squared is 4, plus 4 is 8. This is also 8. So there is our graph. I'm going to go down to 30 then. So in 30, is it plus 27 or minus 27? Plus. So in 30, they want us to find again the vertex. We'll list the A, B, and C are 1, negative 10, and then C is 27. Negative B, so positive 10 over 2 times A. So 10 over 2, so that's going to be 5. Once I know what my vertex or my x coordinate is, I'm going to substitute that back in. So 5 squared minus 10 times 5 plus 27. So 5 squared is 25, minus 50 is negative 25, plus 27 is 2. So 5, 2 is my vertex. So that graph. Oh, how does that move with that? That's weird.
Dang, nabbits.
Oh, it's all supposed to be together.
Kinsey, why didn't you glue the graph together?
I'm sorry. I'm just the worst.
You had one job.
You didn't put we all have 3 different red pens.
Yeah. I have the same in this. Oh, wait. I don't know.
Are you so
I don't know.
Remember when Miss Robbie was like, don't steal my pens. I had like one of her pens. I know it was like a pen. I found them. And she like put it. So that the rest of the week I asked her for a pen because she stole mine. She's like, don't you have your own? And I told her she stole mine. That was mine. And I was like, yeah.
I remember she always had a Pepsi Wild Cherry.
Yeah. And then you would have to sign up on the like wall. Oh, check my
Yeah. Yeah, and it always took forever.
Okay, so we have 5, 2 here is our vertex. Then we have to pick a couple points around that. So I'm going to make my table of values. So 5, 2. So I'm going to put 4, 3,
6, 7.
6, and 7. Now when I go to substitute those in, if I put 4 squared in, that's 16 minus 40 plus 27. So is that negative, or that's 3. This is also going to be 3 then. And then finally, 9 minus 30 plus 27. So that will be 6, right? Same thing here. So there is our parabola. And again, they didn't ask you to solve these, they just wanted you to graph them. All right, so 31 then. These they wanted you to solve. Is this the one that's way off the graph? Or no, 31 they didn't want you to.
This one was like half off.
35 was off. Oh yeah, this one was half off. So x squared plus 20x plus 93. Big numbers. So again, so our vertex, we define our A, B, and C. So negative 20 over 2 times 1, so it'll be negative 10. When I go to put that in, I get 100 minus 200, and then plus 93, so that's a negative 7.
Wait, what did I do? I got like negative 200 something on this one, and that's why I was like,
Yeah, this is going to be positive 100. This is going to be negative. This will be 93.
I thought they were both negative or something, and that's why I was like, no way she's giving us.
Yeah. So it's well off, or it's off the edge of our graph. But obviously, we can kind of sketch this one here. Negative 10, negative 7. So we're going to do negative 9, negative 8, negative 11, negative 12. So it's going to be negative 6, and then negative 3. So you can kind of just assume it's going to go that way as well. And then finally 35. This is the one that I think the It's hard to figure out because I don't think it actually touches. I think, let's see.
So.
Okay, so we want you guys to solve this one. So x equals negative d. So opposite of negative 2 is going to be positive 2 over 2 times 1. So 2 over 2, which is 1. So 1 comma. So then, yeah, 1 squared is 1. Minus 2 minus 24. So this is going to be a negative 25. So well off our graph. So then you're like, and I told you that wasn't going to happen, so I apologize. It did. Oh, it happened.
Oh, it happened already.
So, okay, so we have 1 negative 25. If I try some different numbers, so I put 0 and I get negative 24. We're at least headed in the right direction. We want to hit 0. Then I could do like 3 or negative 1. So 3 would be 3 squared is 9. Minus 6 is 3 minus 24 is a negative 21. So again, what you can do if we're off the graph completely like this, you can kind of keep going. Now, I won't give you one like this. You can kind of keep going until you get it to work. So we get up to 5. 5 squared minus 2 times 5 minus 24. So this is 25 minus 10 minus 24. That's still negative. Yeah. You have to keep going. Sorry, this is way worse than I realized. So you want to keep going until you got to hit 0. Sorry. You're like, I'm done with you, lady. Okay.
I just put a question mark.
You do realize I've seen answers, right?
Well, anyway, no one has
Gold. It's important. It's gold. Not vocab.
Why are you telling me this? But I can't picture it in my head, so I don't know what I'm talking about.
I'll stop.
Give me one.
Ooh, nice. No, Sid. No, I think Jacob's got a piece of the elbow. Ah, no, Sid. It's 4 letters and it has 2 E's. Ah, nice. No, Sid.
No, he said light. What? I do not. You stole mine. And then the rest one, I can give you a pencil you can borrow. I don't have any left though. All my legs still in my pencil pouch and it broke. Like last Christmas, I remember Mrs. Big's Christmas tree, it had left on it, and I was like,
The entire time I said every single sentence along the line. My parents were staring at me.
Okay, so
do you know that Maddie's friends with Sidney Slot? She's actually neighbors with him.
I'm actually 30 and my neighbor.
oh. All right, so guys. So we're gonna go on this chart today. Okay, guys. Everything that we're learning is stuff you guys should have learned in algebra. So again, go back to that whole algebra thing. You gotta remember some of that stuff. So We're going to talk about the different types of factoring. So this is going to be our factoring quadratics chart. And if you didn't remember how to do this, we're going to kind of talk about, guys, I need you guys to focus here. We're going to talk about all the different types right away. We're going to kind of put them in this chart to keep them organized. And so this section is technically like prior to doing the next section. And that's, the book expects that you guys know this already, and that you remembered how to factor quadratics from algebra, but it's something that is easy to forget about. It's a tougher topic. So the first thing you always want to try to do, like if you're starting a factoring problem, you always want to try to look for a GCF first. So I'll remind you what that is.
Greatest common factor.
Yeah. So I'll give you guys an example of that. So a problem like this is a quadratic, but it has a greatest common factor. Two and then something else.
4.
Oh, 2x.
2x. So we can factor out a 2x out of these terms. So that means we're going to divide 2x out of them. So I'm going to divide this one by 2x, and I'm going to be left with 4x. Divide 6x by 2x, and I get what kind of 3? Negative. So this would be the factored version of that.
Hey, I like this. I like this.
Remember that a little bit?
I vibe.
Okay, so that's the first type of factoring. So you always want to check for that first. If you overlook that, it makes some factoring really tough, because if I try to factor this problem, one of these 4 ways I'm going to show you down here, it would be impossible. So you always want to check for that, because that's an easy one to kind of knock off and get taken care of if you're able to. So we'll talk about the other 4 main types of ways for factoring. So the first one is called difference of squares. But the way it's going to look, so the name kind of gives it away. And the fact that it's only 2 terms, difference means what in math? Subtraction. So we're subtracting, and squares means they're perfect squares. So we're subtracting perfect squares here. Now notice, this is not a difference of squares. Why not? We just have an x, and then 6 and 8 aren't perfect squares. So that would not be an example of difference of squares. So difference of squares, they have to be perfect squares. Now there's not a lot of steps that go with this one. What it actually just is that I get to write 2 sets of parentheses. And I basically take the square root of each of them. So square root of a squared is just a and a. And then b is b and b. And then I just put a plus and minus between them. But they have to be perfect squares, and they have to have subtraction. It must be subtract.
Must subtract or unless?
What?
Did you say must subtract or unless you subtract?
They must be subtracted. So 16x squared minus 9. This is an example of perfect squares.
they both have the equals first.
They are.
Nine?
Three.
Alright.
What?
Alright, so 16x squared. What two things can multiply by itself to equal 16? So 4 and 4, but then since it's x squared, it's going to be x and x. And then what times what equals 9? 3.
Three.
And then it's just going to be a plus and minus. Now, if you went ahead and foiled this and checked, it would equal that. Now, we're not doing FOIL here. This is kind of reverse FOIL.
Leave.
Okay?
Get it?
Oh.
Reverse, boy.
Wouldn't it be like
Void. Okay. So, I want to practice these first two. So, why don't you in this part of the room go grab whiteboard markers?
I think this is the hard one.
Oh, I mean, consider this one.
But sometimes having it that way can be helpful for other things. So that makes it more useful to do other things. So there's a purpose behind that.
Right.
All right, the middle two, if you guys want to grab whiteboard. No, next.
Sit down. What's the number?
As I do the same.
4.
That's the one I have on the I don't mind how they sound or any. Yeah. I think I have this one.
All right, last couple there. Now, if you actually, I probably should have said this before you grab whiteboards. If you prefer not to do whiteboards and you like just to have more examples, you could always flip the paper over and do more examples on the back, unless you want to do whiteboards. Then throw it away.
Yes.
Never say that word in a sentence class.
Why? He doesn't like that word.
No.
I'm gonna use my favorite marker.
All right.
Are you talking trash?
Hey guys, I'd like you to factor this one. It might be one of the two types we've learned so far.
It might be.
Or it will be one of the two. There's two types we've already learned.
Wait, what's the other?
Yeah. Look at the top thing. What did I say you should always try to do first? You've already forgotten what I told you to do first. It's been 5 minutes. Yeah, you're good.
What's 10 squared?
So try to factor out a GCF first. No. Think about more than that. Yes. 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 But then you want to leave what's left over on the outside. You want to show those that left over. So whatever you took out, so you divide it out of 5 on one of those, and you want to put that on the outside of the front. Yeah, yeah. Yeah, that's better. Yes, yes. We got a full number. Guys, can you grab a different color pen, please? All right, so when you divide, so 5, you're dividing? Oh. Okay, and then also, you're dividing the 5m out. So that means I have to divide each of these by 5m. So this will be m, and then this will be a minus 2. Those m's will cancel. Okay. So you have to take the m out of each of those. So there's going to be one less m in here, here, and here. So it's going to be an m, and that's going to have an m.
Oh, yeah.
So it's like you're dividing that out.
Yeah. This is ringing a bell.
Okay, try this one.
This is my face when Mrs. Donahue uses other variables other than x.
Yes. Careful. Maybe try and see. You should always look to see if it's a GCF first. Those aren't perfect squares. Oh, always check to see. Yep. No, you lost something from there. Yes, I don't know. That's why I'm asking. Yes. 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 Yep.
You divided by 5.
Wait, hold on.
Yeah. 2 by 6 is like, yeah. So you want to look for what's common off of each two.
That's from you, that's why I decided to do it.
It's more like that. And then we do that extra. Yeah, so you want to put parentheses around those.
Del with cheese.
2.4.
Kinsey's Del with cheese.
No, they're not. Yeah, you want to do this. They're not perfect squares. So you try to find out what's common among them. Okay, you got it. Hey guys. So in this case, why are you using numbers that aren't divisible? You want it to be whole numbers. So out of these two, I can take out a 2. So I'm going to divide a 2y out. And what I'm doing is I'm taking it out of each of these terms. So it cancels here. 10 divided by 2 is 5. It cancels one of the y's there. And 12 divided by 2 is 6. And then I'm just adding those. Okay? Guys, make sure you're listening, please, and listening to my feedback for you, because this is something you have to know how to do. This isn't, we're not goofing around with this. I have to make sure you guys know how to do this, especially before going into virtual. So I need you guys to ask questions if you're not understanding. So again, those weren't perfect squares. 10 and 12 are not perfect squares. So careful with that. Okay, let's try this one. There's a new one up there. Type the side now. Which type is this? Oh, yeah. Oh, yeah. Oh, yeah. Yep. Yes. Yep. That. Not quite. You're missing something about it. Where'd your X's go? Yeah, I wasn't talking to you at that point.
Can it be a decimal?
No, you should not have a decimal. Yep. You're missing your X's. Yes. You're missing something on there. Look at the notes for this part. There's something really important that you're missing. Yes.
I got it.
5.
Yeah. So, in order to get this negative into this one, well, first of all, there's no GCF in this case. There's no greatest common factor. Nothing can go into both 4 and 25. So that's how I know I'm going to do this type of factoring. I'm going to multiply to get 4, and that's going to be 2 and 2. That's the difference of squares part of it. 25 is going to be 5 and 5, but it's also x. 5x times 5x gives me 25x. This comes back together to give you this. But then in order to get the negative here, we need a positive and a negative. It doesn't matter which one comes first as long as you have them both. Okay? Alright, try that one. 2 different variables for you there, Abby.
Oh.
Forget the x. Because it's 25x squared. It's equal to and then it's the d5x and 5x. Yep. Yes.
I feel like I have your last
Yes.
side.
Yes. 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 Why did you change them?
Because it-
Well, okay, but you lost your X, though. Your X is gone. Or your X, yes. Yes. Yes.
That actually isn't in the problem, so.
Sorry.
So technically, so not only did you change the variables, then you
Forgot.
took them out.
Caitlin, are you related to Noah Bay?
No.
Okay,
She's got a regular size.
so guys, listen up, please. So in this case, these are both perfect squares. There's no GCF among them. They're both perfect squares, so they both have the square. 36 is 6 times 6. M squared, so 6m times 6m will give us 36m to the second. Those two come back together to give you that. N squared would just be n and n. And then, since it's negative, a positive and negative. Okay? All right. Back to this one, please. Yes, I think, hang on, let me see real quick again. Sorry. I think, no, I think you're good, yeah, I just, not quite. Not quite. Not quite. You can take out more than that still. Not quite. Your second half. Yes. Yes. Yes.
Yeah,
Yes.
everybody.
You can take out more than that. Yes, that's better. Does that make sense?
Yeah, I don't know why.
Yes. Yes.
We're both
Oh.
Only thing is, and.
I beat the Kahoot Kixie.
Yeah, yeah. So this one is the difference of squares. This 12 is not a perfect square. This is when we have to look for a greatest common factor. So we're looking for what's both numbers that go into that. We're trying to find the biggest number that goes into both. Not quite. 6 divided by 6 is, or 6 times 6 is a 12. So out of these two, I can take out a 6n. So I'm going to divide a 6n out of both of these. So, yeah, 12 divided by 6 is 2. N squared divided by n is just n. 6n divided by 6n is 1, and I'm just going to do subtraction there. Okay?
Heck yeah.
Are we feeling okay, or do we need?
Let's just do one more.
Okay, we still, I mean, we have 3 other columns to do, so I just gotta. I mean, we have
Is this
time to
like our
do.
notes for today?
This is all our notes, but we have to finish the chart.
Yeah.
So this is all I know, this is the yellow sheet?
Yeah,
I think it's gold actually.
It's more of yellow. It's really red. You might be covered.
Yay, she used X.
yep. Yes. 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 Much better, yes.
Say yes.
No, we didn't take out enough. We didn't divide correctly. 6 doesn't go into 9. Yes. 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 Yeah.
Oh.
Yes.
Oh. Yeah. Oh.
Yeah, that looks good. I didn't see that.
What if Harry Styles is our math teacher?
I'm gonna stay after school every day for extra tutoring, if you know what I mean. I'm just kidding, I'm just kidding.
Are those all perfect? Yeah, these are perfect squares. I don't know if that's helpful to know that list. Yeah.
I know.
So if the numbers aren't on this list, they're not both on there, then it's not going to be the perfect squares. So 9's on there, but 12 is not. So that tells me already that I have to go back to a GCF. But again, you should always look for that GCF first. So if it helps to write this list down, that's fine. So I can take out a 3 out of each of these, but also an x, 1 second. Dividing a 3x out of each of these, I'm gonna be left with 3x and then a negative 4. Yeah, question?
Are those squares above 100?
Yeah, but I won't give you many that are much bigger. Yeah, 121, 144, I mean, it's forever. I mean, there's infinite perfect squares.
Infinite.
All right?
To infinity and beyond.
Oh.
Who said that?
That's like
Oh, shoot.
Okay.
oh,
Yes.
oh, first one, guys.
Yeah.
I had it done. Of course, Kinsey gets
Yeah.
it right.
Yeah.
Oh,
The only thing is you're missing the last.
yes, fire.
Yeah.
Shots.
I think better eat.
You got it too, Kissy.
That's all you guys needed with the list? Yes. So that's 9 doesn't go into 49.
Yeah.
So those are both on the perfect square list.
Whoa, you call that an apple.
I know, I like to have it forwarded. It's like you just make it home with me. Yes.
I can take some off your hands if you want.
I do like, I just don't like the banana applesauce. Yeah. I do like it, I just, it's,
If you have a spork, I'll get one right now.
I can't eat that fast, during lunch.
Do you have one of the sporks?
Okay, so this one, both of these numbers show up on our perfect square list. So 7 times 7 is 49. So 7x, 9, or 3 times 3 is 9, 3y, and then just a plus and minus. All right, why don't you guys set marker boards aside? And then go to our next, set them aside, please, don't put them away. Hustle.
Just like really bad.
Okay. All right, so the next type of problem, this one's my favorite one. I had a favorite type of factoring.
Favorite kid?
So it's x squared plus bx plus c. What do you notice about this compared to what's up here?
There's another one.
Missing an A.
It's missing an a. What does that mean for us in terms of a? What is a?
It's gone from one.
It's actually 1. So a is 1. So the type is when a equals 1 and we have 3 terms. Okay. So this one is kind of a reverse FOIL idea. So it's kind of just like a puzzle trying to figure it out. So I will show you an example. We'll write the steps kind of as we go. So let me.
Isn't that the same equation we did for homework?
It's similar, but again, but the a is not 1. Like a could be 1 in
Oh.
this case, or a is 1. We're going to do x squared minus 5x minus 14. Okay. So what we're doing here is kind of a reverse FOIL. I want it to look like 2 sets of parentheses when I'm done. So I know that it's always going to start with, if it's x squared, what do I know it's going to start with? What do those two have to be for FOIL? X. So x and x. So we know it's going to start with x and x. So that's what I'm going to write down here as well. I'm going to explain how to do it up here, and then I'm actually going to do it with the numbers down here. So in terms of FOIL, the L in FOIL is we multiply to get this number. The O and I in FOIL come from adding 2 numbers, or we take the O and I and add them together. So I want to multiply to get this negative 14. And I'm going to call that C. So in general, the last term is C. So I'm going to call it C. So multiply to get C. but I want to add to get that middle term. So I want to add to get 8. And that's what these two numbers are going to be. So in this case, I want to multiply to get negative 14. But when I add those numbers, I want them to be negative 5.
Oh, I remember this.
It's like a puzzle. Multiply to negative 14, but add to negative 5.
Negative 7.
Negative 7, positive 2. That's the only set of numbers that would multiply to negative 14, but add to give me 5. So this would be my factored version, my FOIL version of that. Just so that you guys can see one more, let's do another one. Let's do y squared plus, 8y plus 15. So I know this one has to start with what and what? Y and y. I want to multiply to get which one? 15. But then I want to add to get 8.
5, 3.
So 5 and 3.
3.
Either one. It doesn't matter which way you write it.
Kids just have
Right? So that is a method you should have probably learned in algebra. It's been a little while. I like those because they're, I know they like I have to figure something out that will work. It's kind of finding a puzzle. So
She likes puzzles.
I do like puzzles. So you guys still have your whiteboards, so why don't you guys grab those? We'll try a few more here.
So does Kinsey's mom.
I like puzzles too.
Can I go to the bathroom real quick?
Hurry. Learn. Puzzle.
Run.
X squared plus 4x minus 32. So again, it has 3 terms. The a is 1, so we know we're going to do that type of factor we just wrote down. So you have to think of things that multiply to give you negative 32, but add to give you 4. Yes. Careful though, it's a positive 4. You're good. You're good, you're good, you're good. Yes, do you see the difference? Yes.
It doesn't work.
There you go, good job.
It doesn't work.
It does though.
No. There's no way.
Okay, so just saying that, it's not really helpful. So I would start listing numbers. So if you're ever struggling, you can start listing things. 1 and 32, 2 and 16, 4 and 8, 6 and 6. But notice it's negative. So those could all be negative. There it is. So if you need to make a list, it might be good to make a list of the factors. So this ends up being x times x, multiply, so negative 4 and a positive 8. That multiplies to give me a negative 32, but adds to give me a positive 4. Okay? Give you guys some smaller numbers just because. So let's do so we'll work with a little bit smaller number there. Nope, it doesn't add to give you that 4.
Oh.
Yep. Yep. and 4. The x is going to be 1. Yep. Yes. 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 Oh, no. Sorry.
Pretty excited.
Yes, that adds, when you add those numbers together, that will give you 1. 4 minus 3 gives you 1. So here's another set of factors. There you go. That makes sense. So it has to do both things.
Yeah.
Yes.
Angel.
Okay. So in this case, again, if you're struggling, 1 and 12, 2 and 6, 3 and 4. Those are all the things that multiply to give me 12. But since this needs to be a negative, one of these needs to be negative. Get that to be a positive 4. It's negative 2, positive 6. That's our set of factors. Try this one. Think about what that middle term would be. Or right. Yeah. Yes. Yes. No, not quite clean.
Oh, I know.
What's in front of the x, you guys?
1.
A 1. So you're adding to get 1.
Oh.
Only thing is something should be negative. So there you go. Yep, sorry. Wrong thing, wrong signs. Wrong signs.
Wait, but don't we have to add up the 1?
But a negative 1?
Oh, maybe.
Yeah. Only thing is there should be an x over there. Yeah. 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 But this needs to be a negative 1. Yeah. So yeah, in this case, it's like there's a negative 1 here. So I want to multiply to get a negative 20, but then when I add them, they should be a negative 1. So if I do negative 1 and 20, negative 2 and 10, negative 4 and 5, that'll give me a positive 1, but I want it to be a negative, so I can also flip that. And so it's going to be x minus 5, x plus 4. Okay? All right, let's try one more.
One more.
One more. Oops, what am I doing? No parentheses. Sorry, that should be a minus. Kind of a challenging one.
Easy
Good job, Bennett.
Easy girl.
No.
Mine easy girl.
Yes, good job. No.
Oh.
You want to multiply with the last one.
Easy.
A bit more.
Silly man.
Yes.
Oh,
Yes.
oh, wait.
No, you're not multiplying to get the right one. Yeah, there you go. Your signs are a little goofy. You're not multiplying to get the right number. Yes. Nope, you want to multiply to get this one, you guys. There's not a whole lot that multiplies to give you that one. That doesn't multiply to give you that. Yes. Yes. So what multiplies to give me 11, you guys?
11 and 1.
11 and 1. But then, 11 times 1. That'll give me a positive 11. But how do I get a negative 12 from that? They can both be negative. If there's two negatives, when you multiply them, they become a positive. When you add them, they're a negative. So x minus 11, x minus 1. Okay? Why don't you guys clean up boards? We have a few more things to do still.
You just get that on my structure.
That would be awesome, I guess.
Yeah.
Sorry.
Probably couldn't do better.
All right, we're skipping one of the, we're skipping that column there, we'll come back to it. The next one we need for the last one. We need it as a helper.
I bet that surprised them. Yes.
Used to like Robert Irvin.
Lucky, it's the Evans.
Crikey.
That's their TV show.
Crikey.
That's their TV show. Crikey, it's the Evans.
Be quiet. In Australia, right?
All right, so the one we're skipping over to, I use this kind to do this one. So I want to teach you this one first. It's 4 terms though, so it goes 2, 3, there's gonna be another 3, and then 4. Yeah, we did this chart as algebra. I mean, you guys did this in algebra, if you had me.
I had you.
Okay, so I'll do an example down here. So this one's a little bit wider, so I'm gonna try and make it small. So it's 2a to the second plus 8a minus 3a and then minus 12.
4.
It's 4 terms. Now, I don't want to combine like terms. We can normally, but we actually like it this way because this will teach us how to do this type of factoring. Normally you'd want to, but you won't see many columns written this way. So kind of this, but we need this to be able to do this. So we're going to do this by grouping, because if you look at these don't all have a GCF. There's no common factor among all 4 terms. So what we're going to do is we're going to group these into pairs and factor them separately. So I'm going to factor the first half and then factor the second half. So we're going to factor each of the pairs. So what can come out of those first 2 terms? So a 2 and also a A. So a 2 and an A. I'm going to pull that out. When I take that out, I'm left with A plus 4. Okay. Then, out of the next 2, what can I take out? A negative 3. So I'm going to take that out and put it right here. And I'm left with A plus 4 as well.
Oh, snap.
So that's not a coincidence. That's supposed to happen that I'll get the same thing twice. So what I'm going to do then is this is where the grouping comes in then. This is the same factor, so now I'm going to factor that new one out. So I'm going to take that GCF, and then I'm going to leave the leftovers. So this is my common factor, which is A plus 4. If I take that out of those, what am I left with? 2a and negative 3. So I took the A plus 4 out, and I'm left with 2a minus 3. So that is it factored. Now, if you were to FOIL that back through, it would equal what's up there. And that will work every time if the 4 factors are factorable, which I'll give you one second. Do you want another example of that? Okay? Alright. So, okay, so guys, if you're struggling with this at all, this would be a great thing on Monday when we have our little Google Meet. Tell me we can do that. Otherwise, also tomorrow in the morning, if you want to, you could always meet with me. I am calling people who need to meet with me, who need to do like corrections or a retake or something like that, but most of you guys are all okay. Those of you guys online, you got an email if that was the case for you. So I'm going to show you guys the last of the kinds, and that one requires that you know how to do this last one. So this one has 3 terms, but A is no longer 1. A is not 1. I'm sorry, we're going to kind of go up to the wall here, but you have until Monday 4 p.m. to get this homework done. And it's a worksheet. So, yes, that's a good thing. Okay, so let me. Okay, so this is going to be our example. So 2a to the second plus 7a plus 3. I'm going to tell you guys right off the bat, some of you guys, if you didn't have me as a teacher, you may not have learned this method, but I'm going to tell you guys that with teaching, I've taught for 19 years, and over that time, this has been the method that's made the most sense to students. So I learned it from another teacher, so I taught it other ways in years past, and this is the one that kind of had the least amount of issues. If you know another way, or if you want to learn a different way, I can teach that. I'm just going to teach the one way right now. So what we're going to do with this is, first of all, always look for a GCF first. Is there one? No. If there's a GCF, sometimes the problem can end up looking like one of these. So if there's no GCF, which this one doesn't have, then we're going to use this method that I call splitting the middle. So those of you guys who had me, this is going to look familiar. Those of you who didn't, sorry. You'll learn a new method.
I remember this.
I don't either.
All right. Okay. So I'll explain it though. That's why I'm here. I'm a teacher. So
Really?
I taught them 2 years ago. They obviously remembered something. So
Yeah.
okay. So on the top of this, I'm going to take the first and last terms and multiply them together. I'm going to take the ax squared and multiply it by c. And on the bottom, I'm going to put the bx.
Yes.
So I'll show that here. So multiply the first and last terms together. So 2a squared times 3. What is that? 6a squared. On the bottom, I'm going to put the bx, which is 7a. Now with this, the x is supposed to do, it's just supposed to keep us organized. We want to use this to multiply to get the top number, but add to get this bottom one. So I'm going to multiply to get 6a to the second, but add to get 7a.
Yes.
What multiplies to give me 6a to the second, but when I add them, they give me 7a. 6 and 1. So it's 6a and 1a. What I'm going to use those for is I'm going to take this equation and I'm going to split the middle term with those two. So I'm going to replace the 7a and put 6a and 1a instead. So 2a squared, but rather than writing 7a, I'm going to write these two. 6a and 1a. And it wouldn't matter which order you put them in, so the order doesn't matter. And then just plus 3. So this is the same expression as that. They haven't changed it all, I just wrote it a different way. Okay? Now why is this okay for us? What did we just learn? We learned this grouping. It has 4 terms. So now we want to group it. What can I pull out of those first two terms? 2a. If I take a 2a out, I'm left with a plus 3. What can I take out of those next two? A 1. And I'm just going to take the 1 out and kind of put it as like a placeholder, just to hold it there so it looks the same. And I'm going to be left with a plus 3. And again, I know I'm doing this right because they match. So a plus 3 I'm pulling out. And what's left behind? 2a plus 1. Now, if you FOILed that back, it would give you that original thing. If you'd like one more example, why don't you guys flip your paper over? You have a little bit of space back there. I'll give you guys another one. Here's your R's, Abby. Special for Abby.
No.
Let me give you guys a tough one.
R for Robert Irwin.
Right. Staring at you. Okay. So does this have a GCF? No. So that's how we know we have to do this thing. There's 3 terms and there's something in front of the R, or the x squared. So what goes on top is the first and last get multiplied together. So what am I going to put on top? Negative 30 R to the second. What's going to go on the bottom? Yeah, it's like a 1R. Like a positive 1R. R. You're a real pirate. All right. So we want to multiply with this top number, but add to get the bottom. Multiply to negative 30, but add to 1.
5 and 6.
5 and 6. Which one has to be negative? 5. Which one do you guys want to go first? Doesn't matter. 5. So negative 5R, positive 6R. Again, the order you put them in doesn't matter, but the sign has to be, this has to be a negative because I want this to be a positive 1. We're using this to replace this. So I just replace that in the equation. Now I'm ready to do grouping. I'm going to group those. Pull out their GCFs now. So out of these two, I can take out a 5R, right? We left with 2R, but then a minus 1, because 5R divided by 5R is just 1. How about out of these two? Kind of 3? A regular 3, positive 3, because I want them to match. So this is going to be 2R and then minus 1. If you notice, I have the same thing twice. So 2R minus 1. And then 5R plus 3. All right. I think it's kind of like interesting that it works out. There are other methods. Like if you go online and say factor that, you can find other methods to do that. I think this is the easiest method just in working with students. So I have a worksheet for you guys. I would highly suggest having your chart out. The back side is asking you guys to practice some graphing.
Oh, yeah.
They fit, though, I promise.
You promise?
Yeah,
Look at my answer
because
TV.
Otherwise, on the Google Meet on Monday, we'll be like, this is good.
We're gonna riot.
Yeah.
Riot. Math riot.
Like,
Yeah.